Our next lecture is on exercise 1.3 from the topic differentiation. In that, the first example is differentiate or define dy by dx for root x plus root y is equal to root a. So given equation is root x plus root y is equal to root a. Differentiating with respect to x, we get derivative of root x plus derivative of root y is equal to derivative of root a. Now a is a constant, so its derivative is 0, and dy by dx of root x. So here is root x, and differentiating with also with respect to x, so 1 upon 2 root x plus 1 upon 2 root y into dy by dx. So derivative of root y is 1 upon 2 root y into dy by dx. So now just simplify and eliminate dy by dx from this equation. Write dy by dx is equal to 2 root y upon 2 root x. So here 2 will cancel each other, and we can write this root y and root x in one square root only. So dy by dx is minus root y by x. Now find dy by dx, x root x plus y root y is equal to a root 2. So what is given? X root x plus y root y is equal to a root 2. We can write it in the form of one exponent only using laws of indices. X raised to 1 plus x raised to half is x raised to 1 plus half 3 by 2. Y raised to 3 by 2, a raised to 3 by 2. Then differentiate with respect to x. After differentiating, we get 3 by 2 into x raised to 3 by 2 minus 1 plus 3 by 2 into y raised to 3 by 2 minus 1 into dy by dx. Because we are differentiating with y x, and here is there is a variable y, so we cannot differentiate with respect to x directly. So we have to differentiate it with respect to y first and then y with respect to x. And now a is a constant, so its derivative is 0. So what you get? 3 by 2 y raised to half into dy by dx is equal to minus 3 by 2 x raised to 1 by 2. This 3 by 2 cancel each other, this root x, and it becomes root y. So dy by dx is minus root x upon root y. So we will take in one square root. Dy by dx is equal to minus square root of x upon y. This is the derivative of the given function. Now the next example is x plus root xy plus y is equal to 1. Differentiate this with respect to x. Derivative of x plus derivative of root xy plus derivative of y and derivative of 1. Now derivative of x is 1. Derivative of root x, root f of x, derivative of dy by dx of root f of x is 1 upon 2 root f of x. 1 upon 2 root f of x into f dash of x. Here derivative of y is dy by dx. So 1 plus 1 upon 2 root xy into dy by dx of xy, first function as it is derivative of the second function plus second function as it is derivative of the first function. So use that formula and simplify it. You get x upon 2 root xy plus 1 into dy by dx plus minus 1 minus y upon 2 root xy. Now take the LCM from both the sides. We get both the equation, both the sides have the denominator 2 root xy. So cancel each other, and we get dy by dx is minus y plus 2 root xy upon x plus 2 root xy. Now the next example is x cube plus x square y plus xy square plus y cube is equal to 81. These are all examples which are based on the implicit functions, where we cannot express x in terms of y or y in terms of x. So differentiating with respect to x, what we get? Derivative of the first term plus derivative of the second term plus derivative of the third term plus derivative of the fourth term is equal to derivative of 81. 81 is constant, so derivative is 0. Derivative of x cube is 3x square. Now here there is a product of two functions x square and y. So first function as it is derivative of second function plus second function as it is derivative of the first function. something is missing. So x square as is derivative of y, and then y as it is derivative of x square. So, and here x as it is derivative of y square plus y square as it is derivative of x, and derivative of y cube is 3y square into dy by dx. Now what we will do, we will collect the terms which contains dy by dx in together and other terms together. Then what we get, dy by dx is equal to minus 3x square plus 2x plus y square upon x square plus 2xy plus 3y square. We will take this term, these three terms to that side. Then this term will be in multiplication with the dy by dx, so it will go to that side in its denominator. Now x square y square minus tan inverse of root x square plus y square is equal to cot inverse of x square plus y square. What is given? This is given. We will take this minus tan square root x square plus y square to that side. So what we'll get? Tan inverse of root plus cot inverse of root. But it is we have studied one formula. Tan inverse of x plus cot inverse of x is pi by 2. So we can use here. So x square y square is equal to pi by 2. Now we will take the derivative of this function. So derivative of the product x square y square is equal to derivative of pi by 2. It is constant, so its derivative is 0. Now here on left hand side, the x square is as it is derivative of y square plus y square as it is derivative of x square. So what we get, x square into derivative of y square is 2y. So 2y divided by dx, and derivative of x square is 2x. So dy by dx is equal to minus y upon x. So all the other terms will cancel to each other. X e raised to y plus y e raised to x is equal to 1. Differentiate with respect to x. Now in first, there is a product of x and e raised to y, and there is a product of y and e raised to x. So x as it is derivative of e raised to y plus e raised to y as it is derivative of x. Then y as it is derivative of e raised to x, and e raised to x as it is derivative of y. So e raised to y, its derivative is e raised to y into dy by dx. Derivative of x is 1. Derivative of e raised to x is e raised to x. Derivative of y is dy by dx. So these two terms, dy by dx, which contains dy by dx, will collect together. So x e raised to y plus e raised to x into dy by dx is equal to minus e raised to y plus y e raised to x. So dy by dx is minus e raised to y plus y e raised to x upon x e raised to y plus e raised to x, derivative of this given function. Now the next example is e raised to x plus y is equal to cos of x minus y. So what is given? E raised to x plus y is equal to cos of x minus y. So differentiating with respect to x, we get d by dx of e raised to x plus y is equal to d by dx of cos of x minus y. So the derivative of e raised to x plus y means x e raised to x plus y into d by dx of x plus y. So the derivative of cos of f of x is minus sin f of x into f dash of x. Using that formula, find the derivative. Now here the derivative of x is 1 and derivative of y is dy by dx. Here is also derivative of x is 1 and derivative of y is minus dy by dx. Then now we multiply e raised to x plus y by this bracket, and also for this bracket we multiply minus sin x minus y. Now we will collect the terms which contains dy by dx to one side and other terms to other side. Take dy by dx common and then simplify it for dy by dx. This will be as it is. This term is in product with dy by dx, so it will go to that side in its denominator. This is the derivative. Cos of xy is equal to x plus y. It is given. So let us differentiate with respect to x. Derivative of cos xy is equal to derivative of x plus y. Here derivative of x plus derivative of y, 1 plus dy by dx, and cos of f of x, its derivative is minus sin f of x into f dash of x, so dy by dx of xy. Now here there is a product of two functions x and y, so we have to use product rule. X as it is derivative of y plus y as it is, derivative of x. Derivative of y is dy by dx and derivative of x is 1. So minus sin xy in bracket x dy by dx plus y into 1 is equal to 1 plus dy by dx. So multiply this minus sin xy in this in bracket and then simplify the function for dy by dx. So this dy, this term and this term, this dy by dx, here it is my plus, so it will come to this side and it becomes minus. Again this minus sign, minus y sine of xy is minus, so it will go to that side and it becomes plus. Now from these two terms we will take dy by dx common. This minus sign will go to that side, minus in bracket 1 plus y sine xy. This will divide to this. We get dy by dx is equal to minus 1 plus y sine xy upon 1 plus x sine xy. Dy by dx is e raised to x minus y is equal to x upon y. Now here differentiating with respect to x using the d by dx of e raised to f of x. We will use the formula d by dx of e raised to f of x is e raised to f of x into f dash of x. So d by dx of e raised to x minus y. Now here d by dx of x upon y, you have to use the quotient rule. Denominator square, denominator as it is, derivative of the numerator, minus numerator as it is, derivative of the denominator. Then again this you have to use here e raised to f of x. Derivative of e raised to f of x is e raised to f of x into f dash of x. So e raised to f of x into f dash of x. So derivative of x minus y is 1 minus dy by dx. And this denominator y square will to come to this side, it becomes y square into the derivative. So is equal to y minus x dy by dx. Multiply throughout this y square in this bracket. Y square into what is the value of e to the power x minus y? It is 1 upon x upon y. Put that value here and simplify it. Y gets cancelled, but you get x into y e raised to x minus y 1 minus dy by dx is equal to y minus x dy by dx. Then taking the terms which contains dy by dx together, taking common dy by dx and simplified for dy by dx, we get this equation, this expression. This is the derivative of the given function. Here x plus sine of x plus y is equal to y minus cos of x minus y. Differentiate with respect to x. Derivative of x is 1. Derivative of sine of x plus y is sine of f of x is cos f of x into f dash of x. So dy by dx of x plus y. Here dy by dx minus dy by dx of cos x minus y is cos f of x is minus sine f of x into f dash of x. So after using the or finding the derivatives, we get the equation of this form. Okay, then we multiply this bracket by cos x plus y and this bracket by sin x minus y. Then we will going to collect the terms which contains dy by dx to one side and other terms to other side. Then we will take dy by dx common, and the terms which do not contain dy by dx to other side. Then we will divide this right hand side by this sin x minus y plus cos x plus y minus 1, and we get the required answer. This is the derivative of the given function. Okay, this is some examples from exercise 1.3. We will continue the same exercise in our next lecture.